In this lesson, we're going to talk about scaling and specifically how to use an architect scale. Now, for the rest of this class, you'll be using Autodesk Revit and doing some CAD modeling, but it's always good to understand how to use an architect scale because in many situations, you might be going into an existing facility and doing updates to it, and the drawings of that facility might only be available in paper. So you need to be able to retrieve dimensions off of the paper in order to model new things in Revit. Now, later we'll see in Revit that the scale is all taken care of for you. But again, we're just going to lay a foundation for how to use an architect scale and what does it mean when I see a 1/4 inch equals a foot? What exactly does that mean? Now, some of this information is covered in the Architecture Residential Design, Drafting and Design textbook in Chapter 4, Drawing Instruments and Technical Sketching. But I'm going to go a little bit further than what the book does. So first of all, some examples of some drawing scales. A lot of times, especially in the architecture world, we're reducing something to fit on a piece of paper. Obviously, I can't fit a full-scale house on a piece of paper, so I have to scale it down. So some examples, common architectural scale, 1/4 inch equals a foot for residential. When we get into some commercial construction, we're dealing with bigger buildings. A lot of times we'll use 1/8 inch equals a foot. And then sometimes we'll use 1/2 inch equals a foot for details. For example, I might do a floor plan at a 1/4 inch equals a foot, but then if I want to show some kitchen cabinet details, I'll go up to a 1/2 inch equals a foot. It is possible to have some enlarged scales as well. So again, this would be more of a mechanical example if you wanted to take a part in your watch, for example, and blow it up and put it on a sheet of paper and detail it. Obviously, we're going to need to scale that up. So taking a look exactly what a 1/4 inch equals a foot means. First thing I want to do is figure out the scale factor. So if I have a 1/4 inch equals a foot, that's basically the same thing as saying a 1/4 of an inch equals 12 inches. And I want to get a 1 on the left side, so that way I can have a 1 to something ratio. So I'm basically going to take both sides times 4. That will give me a 1 on the left side, and then a 48 on the right side. So that gives me a scale factor of 48. So basically what I'm saying there is when I have a 1/4 inch equals a foot drawing, a 1/4 inch on the paper represents a foot in the real world. So anything on paper represents something 48 times larger in the real world. Now that scale could be used to figure out other things such as text height, drawing size, things like that. 1/8 inch equals a foot, very similar example. I'm going to take both sides times 8. That's going to give me a 1 to 96 ratio. So as you can see, this represents something 96 times larger. So this is actually half the size of the 1/4 inch equals a foot. So if we're actually laying things out on paper, we'd have to know what the real world object size is and what the paper size is. So here we have a scale of 1 inch equals 4 inch in the real world. And therefore we have a scale factor of 4 once I reduce that down. Again, if we're going to lay it out on paper, we'll have to consider the size of paper, measure the size of the object, and then cross multiply basically to figure out exactly how big we want to draw something. I want to get into the specifics of that since we're not going to actually lay this out on paper. But these slides are up if you want to look through them a little more slowly here. And basically, if you know one value, you can calculate the others. So there's multiple different types of scales. We're focusing on the architect scale, and we're using a triangular architect scale, so that gives us 6 sides basically that we can measure on. So we've got 11 different scales represented on those 6 sides. And on many of the sides, there's 2 scales, depending on if you read from the left side or the right side. So we'll look at that more in just a moment. So here is a close-up example of what the architect scale looks like. So here I'm dealing with a 1/4 inch equals a foot size. And at the beginning of each scale, you'll always have a foot divided into a certain number of segments. So in this particular case, we can see that we have a foot divided by 12 segments. So this represents a foot. Since I've got 12 segments, then that means each little increment is equivalent to an inch. As I continue on to the left here, this would be my 1 foot, 1'6", 2 foot, and so on as I go to the left. Now the 92, that's a measurement that's coming from the left side, so I don't really pay attention to that particular value. I just know that that's 6 inches as I'm going to the left. So if we take a look at a sample line here, using the 1/4 inch equals a foot scale, looks like we've got a 6 foot something line. So we already determined that each small gradation is an inch, so it looks like it's over 3 inches. So this one would be 6 foot 3 inches long. Here's another example. Looks like this one's at the 5 foot mark, and it looks like we've got 8 marks here, so 5 foot 8 inches. So when we do the 1/8 inch equals a foot, we're dealing with half the size now, and therefore it's harder to fit 12 little gradations in a foot. So we only have 6 gradations, so we have 2 inch increments now. And again, we're going from left to right this time, so 1 foot, 2 foot, 3 foot, 4 foot, etc. So as I take a look at this one, looks like I've got 4, 5, 6, 7 feet and 2 marks, so that's going to be 4 inches, since they're each worth 2 inches apiece. So 7 foot 4 inches is the measurement of that line. Here's another example of a 9 foot 8 inch line. Again, notice that it's 4 marks over, they're each equal to 2 inches. Now with a 1/2 inch equals a foot, this is a little bit larger scale, so we can actually fit 24 little segments into a foot, so therefore each segment is worth 1/2 inch. So we can get a little more precise the larger the scale that we use. So if I take a look at this one, again, don't get confused by the fact that it's pointing to the 9. That's the number as it's running from the left side. We're looking at the fact that we've got 0 here. This would be 1, 2, 3 feet. And then looks like I've got 3 feet 6 inches, 7 inches, 7.5. So it's looking like 3 feet 7.5 inches. And again, just another example of what another scale would look like. Now we can use this scale to mean different things. We can say it's a 1/2 inch equals 10 feet. So that would obviously change what each little increment defines. Each one would be 5 inches in this case. But we'll stick to just the basics, the 1/4 inch, the 1/2 inch, and so on as we look at this. Here we have a 1.5 inch equals a foot. So now we can even go all the way down to 1/4 inch marks. We've got so many gradations in there. And then we can even have 3 inches equals a foot. Now we can have so many gradations that they equal 1/8 of an inch. So obviously, the larger the scale, the more detail that we can get down to. So let's take a look at the scale itself. So here is an architect scale. And as I said, there's basically 6 sides on here. Most sides have dimensions running from the left and the right. The exception is the 16 side, where they're just broken up into 1/16 of an inch increments, and there's none that counts over from this side. But you can see the other ones. Here's 1/2 inch going this way, 1 inch equals a foot going this way, here's 1/4 inch going this way, 1/8 inch going this way. So as discussed on the slide, we'll zoom in here so you can see this a little better. 1/4 inch equals a foot. So as I count these, this is 1 foot, and there's 12 little gradations, so that means each little mark is equal to 1 inch. So if I want to count from the left side, here's 1/8 inch equals a foot. And again, this time I only have 6 marks, so they're each worth 2 inches. So let's apply this to a drawing and see how to draw, or how to scale a drawing, excuse me. So here I have the school building that I've drawn, and as you can see, it's at an 1/8 inch equals a foot, a common commercial scale. And I want to take some measurements of this building. So I'm going to begin by measuring the overall width of this building. So as I'm measuring, I can see that I've got 48, 49, 50, 50 foot and some change. So I'm going to slide my scale over so that it lines up with the 50 foot. Then I'll come back over here to the left side and figure out how many inches I have. Let's see if I can zoom in here and get a good look. So as I line the right side up with 50 feet, this one's looking like it could be 6 inch, 7 inch, 8 inch. I'm going to go ahead and call it 8 inches. So this would be 50 feet, 8 inches. Let's measure across here. Looks like I got 20 feet there. Take another measurement here. That one looks like it's exactly 10 feet. So again, 8, 9, 10 feet to get me there. So let's jump to another view. So I'm going to zoom in closer to this middle area here. So this classroom is in the center of this drawing. I'm going to take a couple of dimensions of this area here. So now I'm at the 1/4 inch equals a foot scale, so I'm going to be measuring from the right side. So if I want to know the width of this room here, again, I'm going to line it up, and I can see it goes 10, 11 feet. So it's between 11 feet and 11 feet 6 inches. I'm going to slide it over to the 11 feet. And then now I can come over here and count the inches. And it looks like it's about 4 past. So I'm going to call it 11 feet, 4 inches. There we go. And then maybe I'll measure the width of the room going the other direction here too. So again, as I'm counting up, I've got 12 feet, almost 13 feet. So I'm going to slide over either to the 12 foot 6 and add my inches to 6 inches, or slide all the way back to 12 feet. And then I can count up my inches over here. So I'm getting about 12 feet 11 inches, give or take. So then I'm going to actually zoom in a little closer even. So I'm going to now take a look at this room right here. And as you can see, I'm going up to a 1/2 inch equals a foot on this one. So I'll find my 1/2 inch side. Now remember, the 1/2 inch is the one that's broken up into 24 segments. So I can actually measure to 1/2 inch increments now. So I'm going to measure the width of this room. And again, I can see I've got 4, 5, 6, 7, 8, 9, 10, 11 feet and some change. So this 5 represents where the 11 feet is as I'm counting over from the right side. So I'll slide back over to the 5. And then I'll count my increments here. Zoom in so we can see this a little better. Oh, so it looks like I've got 1, 2, 3.5 inches. So I'm going to call that 11 feet, 3.5 inches. So if we compare that to the previous drawing, this represents the same width, but as you can see, I've got a different answer there. So again, the larger the scale, the smaller the increments and the more precise that I can measure. So to sum it all up, again, you're not going to be drawing with the scale. This isn't a hand-drawn class, but it's always good to understand what the scales mean and how they work so that you can actually go back and measure some existing drawings and pull those dimensions into your drawings.